Welcome back to the course on computer network and internet protocols. So, in the last class, we were discussing about the concept of software defined networking, and we have looked into the basic architecture for the software defined networking and the broad concepts around that. So, today we will gradually go towards an implementation perspective of the software defined networking and the software component of it, where the routers or the network devices are software controlled. So, we will look into that what type of software or which software will actually control this entire networking architecture. So, in this context, we will look into a specific open source protocol implementation, which is called OpenFlow, and in subsequent classes we will look into a demonstration of ISDN network by utilizing OpenFlow protocol stack. So, let us go to the details of that. So, as we are discussing that traditionally in the network community, the innovation is a closed innovation. So, closed innovation means in a single box we have the individual components or individual networking components which should be there. Like here, if you just follow this diagram, you have the packet forwarding hardware, the network operating system, and different kind of networking application. Everything is bounded on the single bounding box. So, this contains the router hardware. So, you can talk it as a router. So, this contains the router hardware, and inside the router you have the hardware component which is implemented in TCAM, or in traditional router it is CAM. So, one of this type of hardwares. On top of that, we have the network operating system that actually implements the different kind of networking protocols and the routing control protocols, and on the top of that we have different kind of applications like the firewall application, the packet forwarding applications which are there inside the router. Now, whenever you purchase a single router, this entire bounding box that comes from a vendor, and that is why we call it as a closed innovation. So, closed innovation basically says that both the hardware as well as software along with the applications which are associated with your network functionalities, everything is coming from the same vendor as the same package. As a result, the problem comes in terms of first interoperability, the second is the network manageability. So, if you purchase a Cisco router and a Netgear router or a HP router, in general it is the burden of the network operator to look into the individual configurations of the routers and then configure them in such a way so that these routers can talk with each other or forward packets from one router to another router. And these operating systems, they being the vendor specific, like whenever you are purchasing a router from Cisco, the network operating system is coming from Cisco Internet Operating System, iOS or any other operating system. Whenever you are purchasing a router from Netgear, the operating system is coming from them. So, because the operating system and the firmware are hardware dependent and it is vendor specific, and that is why the configuration or handling the operating system for a network administrator who will actually give the input of the networking policy, for them this entire architecture becomes difficult to handle. So, because of that we gradually move from this kind of closed innovation network to a open innovation network. So, the open innovation network basically talks about something like this. Now, the vendors will only supply the packet forwarding hardwares, which are the dumb switches, or we call it as the open switches or the blind switches. So, there are different terminologies which are being used in the networking community. So, you are getting this packet forwarding hardwares from different vendors, and then you have a central network wide operating system, this network operating system which is a open operating system. So, now we are basically segregating the hardware from the software, or in routing functionalities as we are discussing in the last class, we are separating out the data functionalities or the data path functionalities from the control functionalities. So, the data path functionalities are still implemented inside the hardware, inside this packet forwarding engine, where you have this TCAM implementation. So, it is still in the hardware side, but on the software side you can choose your own software which you can utilize to configure all these hardwares altogether. And then on top of that you can write your own network applications, and the advantage is that now you do not need to bother about whether your routers are coming from Cisco or from Netgear. You can purchase the hardwares from any vendors in the world, and then you can connect it in your network, and all these hardwares should be programmable with the help of this network operating system. So, the only modification in the hardware side is that now these hardwares, the packet forwarding hardwares, are programmable hardware. So, these are programmable hardware. That means, with the help of this network operating system, you can dynamically program the hardware, so that you can install the forwarding rules, or you can install the configurations dynamically based on the network operating system that you are choosing. So, the question comes that with this kind of SDN architecture, where we are gradually moving from a closed innovation network to an open innovation network, what are the requirements and how will you fulfill those requirements? So, the things come from here. So, this was the broad SDN architecture as we are discussing. So, we have the infrastructure layer at the bottom. So, this infrastructure layer have different kind of hardwares, like you have the servers, you can have the open switches, you can have the top of rack switches, you can have edge routers or data center gateways. Then we have a control layer in between, and that control layer has all the control functionalities which are inbuilt inside that. And on top of that you have different kind of networking application, the application layer where you can write down the network application like the flow optimizer, the network topology viewer, network management application, policy enforcement application, load balancer, network automation, network bandwidth management, whatever application you can think of and you can design on top of that. So, this control layer which works like a brain of this entire network, we are making it logically centralized. So, now the architecture is that we have multiple hardware components which are there, and all these hardware components are connected to a central controller, and this controller actually contains the control layer. So, these hardwares are connected over the network as they are there in the normal network. So, because these are just a blanket hardware, or this doesn't have any kind of software inbuilt, we call it as the blind hardware or the open hardware, and in case of normal networking terminology, rather than calling it as a router, we call it just like a dumb switch. So, this dumb switch does not have any knowledge about what to do, neither layer 2 knowledge nor layer 3 knowledge. And this controller, whenever you are programming this controller will actually configure these dumb switches dynamically, put the intelligence inside the switch. Now, this controller has all these different kind of module which can be there, like you can have a GUI module, the cluster module to form a cluster, the layer 2, layer 3 module to implement the layer 2 and the layer 3 functionalities of the network protocol stack, the VPN module to create a virtual private network, the quality of service module or access control list module to implement access control list or quality of service, DHCP module to implement DHCP protocol, and the plugins which we call normally as the southbound plugins to interact with the programmable infrastructure layer. So, here you have two different interfaces from the control layer. From the control layer, one interface that talk with the applications, different kind of applications, that we call as the northbound interface, and then with the control layer to the infrastructure layer, we require another interface which is called the southbound interface. Now, the task of the northbound interface is to understand this individual application layer program and these application layers programs are implemented by utilizing your favorite programming language. So, you can use Python, you can use Java. Accordingly, you have to choose the controller. So, for example, in a typical SDN network, if you are familiar with Python, you can choose the POX or RU kind of controller. If you are familiar with Java programming language, if you want to implement your application using Java programming language, you can use OpenDaylight controller which support Java programming language. So, you can write down this application with your favorite programming language, and the task of this not bound interface is to understand what is written inside the application, compile the application to the corresponding network protocol, and then map it to one of these modules which are there inside the controller. So, you can utilize this module to write your own program. So, for example, with the help of you can write a load balancer application where you can utilize the layer 2, layer 3 forwarding module to forward the packet to a specific destination. Now, this control layer from these individual network functionalities, they have to convert it to the rules that will be programmed to the router, and whenever an incoming packet comes, that rule will be executed. So, from this individual network protocol to the rule conversion, that is done by the southbound interface. So, we will look into the details about how these rules are being implemented and how you convert a particular protocol to a corresponding rules in the SDN terminology or in the OpenFlow terminology. So, what we require in summary? So, to talk between the network operating system and the corresponding infrastructure, we require an open interface to the hardware, so that you do not depend on the corresponding vendors to program your network. We require an open interface to the hardware for that. The second thing is that we require an open API for the application development, so that any application developer can develop a network application. And the third thing is that we require an extensible operating system to convert the programs to the rules. So, these applications, they are nothing but a program. From that program, we need to map it to the corresponding rule, which will be executed at the TCAM hardware of the packet forwarding engine, which is there inside the switches. Well, so what is OpenFlow? So, OpenFlow is a protocol for controlling the forwarding behavior of Ethernet switches in SDN network. Initially, this concept of OpenFlow was released by Kinslate program at Stanford, and currently the specifications are maintained by Open Networking Forum. So, the interesting fact is here that now this entire networking architecture, they are becoming open. They are moving from a closed community or from a vendor specific community to an open networking community, where every vendors join all together. So, the vendors are building their hardwares, and the community is building the open source operating system and the interface to interact with the corresponding hardware. So, this helps in two ways. First of all, it makes the innovation specific, or it makes the innovation rapid, because now this entire software is open to the community. You can design your own network protocol and test on a hardware. For that, you do not need to search for an hardware where you can implement your own protocol. You can purchase any SDN supported switch, open switch, and then you can do your protocol implementation on top of this open source operating system. And the second advantage comes from the network management perspective, where the network administrator, they do not bother about reading the 1000-page manuals for from 3 different vendors. So, they can just concentrate on a specific operating system and then try to write their own rules on top of that specific network operating system. So, in terms of SDN messaging interface, as we are mentioning, that from network operating system to the hardware, we have the southbound interface. Then from the network operating system to the application, we have the northbound interface that provides the programming API, and then this network operating system can be implemented in any open source operating system. There are multiple standard industry specific operating systems which are available nowadays. You can explore that. There are this ONOS operating system which is very popular nowadays. There is this RIU controller which is a lightweight controller. Currently many industries they are utilizing RIU controller to write network programs, and then other controllers like Mastro or Open Daylight. So, as we are mentioning, at the application layer side, you have a programming API in your preferred programming language. At the control layer, you have one of the network controller, ONOS, Mastro, RIU or Open Daylight, and at the infrastructure layer, you have this OpenFlow supported hardware, and this southbound interface is controlled by this open interfacing with the hardware. That is the OpenFlow specification that we are talking right now. Now, let us look into that how OpenFlow works. So, we have a switch. The entire switch, as we are discussing in the last class, we have the control path which is implemented in the software and the data path which is implemented in the hardware or in more specific TCAM type of hardwares. Now, at the control path, we are having a part of the network operating system to interact the client version of the network operating system. You can talk it is there in this software implementation in the switch. That is a kind of very minimal implementation of the control functionalities, just a client version of it, so that you can talk with the switches. And then you have this OpenFlow protocol, OpenFlow client, which is there inside the switch. So, you can call it as the client version of the OpenFlow, and then you have a OpenFlow controller which is implemented in a logical centralized machine. And then this OpenFlow messaging API which normally uses SSL and a TCP kind of message which talk with this OpenFlow controller. Now, the thing is that at the software side inside switch, you have a very minimal implementation, the client version of the implementation, so that you can just receive a message from the controller, parse the message and then configure the switch accordingly. Remaining protocols, the routing protocols and all these things that you do not need to implement inside the switch anymore. So, here is an example of OpenFlow. So, at the switch side you have this OpenFlow client. At the hardware layer we are maintaining a simple TCAM table. So, this TCAM table has multiple fields like source MAC, destination MAC, source IP, destination IP, source port, TCP source port, TCP destination port, and the corresponding action that you want to execute. Now, a simple rule looks like this from the hardware layer side, that your source MAC is star, that means it is a wildcard character, that means you can accept any source MAC field, you can accept any destination MAC, you can accept any source IP. Your destination IP should be 128.9.1.10. The source TCP port and the destination TCP port can be anything, and if that is the case, then your corresponding action will be forward the packet to ETH3. So, this entire thing, entire packet forwarding behavior, we can write it as a match and action pair. So, we have a rule, this entire rule that has a component of match. So, we have certain entries in the tables, and then if there is a match, then you execute the corresponding action. So, here this is one entry in the TCAM hardware table. So, whenever you are receiving a packet, you extract the headers at different layers, extract this source MAC, destination MAC, source IP, destination IP, source TCP port, destination TCP port, all these fields from the packet header, and then make a match with this rule. So, if there is a match with a specific rule, then you execute the corresponding action. So, the action is to forward it to ETH3. So, ETH3 means this particular router where you want to forward the packet. So, here the message that I want to convey to you is that any such network protocol or better to say most of the networking protocol we can implement it in the form of a match action pair. We will see some examples of that as well. So, there is a tremendous power of this entire OpenFlow protocol or OpenFlow architecture. So, let us see one interesting use case of OpenFlow. So, assume that Bob wants his own set of network rules to forward his packet. So, we have a network controller here. So, this is the controller and these are the SDN switches which are the dumb switches as we have mentioned. Now, Bob wants his own forwarding application. Say Bob wants to forward a packet from this router, say router 1, I am naming the routers as router 1, router 2, router 3 and router 4. Now, Bob wants to forward a packet from a machine which is connected with router 1 to a machine which is connected with router 4. This is the destination. So, and Bob wants that the packets need to be forwarded from R1 to R2 to R4. Now, what Bob does, he basically write that this entire thing in a application program inside the controller. So, the controller combines that program, compiles that program, and after compiling the program, the controller simply deploys Bob's forwarding rule in the required hardwares. So, whenever Bob want to forward the packet, these forwarding rules which are there in the respective switches, they get executed and the packet gets forwarded. Now, when Alice wants her own set of network rules to forward a packet, Alice also program the same controller, write her own application on top of the controller, and then the forwarding rules are installed in the routers on through which Alice wants to forward the packet. Now, here you can see the interesting things that all the routers do not need to have all the rules. So, Bob wants to use this router 1, router 2 and router 3. So, this router, or let us not use the term router, let us use the term open switch. So, Bob wants to use these 3 switches. So, the rules are installed on that 3 switches, and when Alice wants to forward the packet, Alice wants the packet to be forwarded from R1 to R4 to R3. So, the rules are installed in those switches. So, if we look into the OpenFlow flow table, the OpenFlow flow table has 4 different components. You have the rule, the corresponding action, certain statistics about packets, the execution of a particular rule, and the priority value which is associated with a rule. So, the idea is something that, so you have a rule. So, the rule is nothing but a set of fields, and that field basically says that in which particular field of an IP packet, or here actually in SDN you can look into MAC, IP, TCP, all the headers. So, in your packet header, which particular field to look into? Theoretically, you can look into any field inside the packet header. You can look into the packet header, and a rule basically specifies what should be or what is your interested value for a specific field inside the packet header, like the switch port, VLAN ID, MAC source, MAC destination, Ethernet type, IP source, IP destination, IP type of service for quality of service, TCP source port and TCP destination port. Now, if there is a match with this rule, that means with these certain fields that you are specifying, then there can be a set of actions, and the actions can be designed by you based on your choice. So, the action can be forward the packets to 0 or more ports in the switch, encapsulate the packet and then forward the packet, modify certain fields in the packet header and then forward the packet, drop the packets if you want to implement the firewall rule, or you can add up your own extension, whatever you can think of. The statistics fields, it maintains certain statistics like the packet counter, the byte counter, number of packets that have been matched with a particular rule and so on, so that it becomes easier for you to get the information from the network. and then there is a priority value associated, which is the priority of a corresponding rule. So, in case of a open flow, whenever you have a set of rules, if there is a match with multiple rules, then the high priority rule is executed in general. Here are certain examples of open flow flow tables. If you want to do a switching, you have to look into the MAC destination field. Because you have to look into the MAC destination field, so you just make a match with the MAC destination. You can ignore other fields, so we put it as a star, as a wildcard character. If there is a match with this particular MAC address, you forward it to Ethernet 2. It behaves like a normal layer 2 switching mechanism. If you want to implement a firewall, you look into the TCP destination port. If TCP destination port is 22, then you drop the packet. So, that is the corresponding firewall rule. So, you can design your own firewall rule like that. So, look into certain fields in the packet header. If there is a match with those fields of the packet header, then you drop the packet. Then forwarding, to forward a packet, rather than looking into the MAC destination, you look into the IP destination. If your IP belongs to this subnet 202.2.star, you forward the packet to Ethernet 2. You can make a flow switching, which is interesting. That means, this flow switching, with the help of flow switching, you can make a convergence between the packet switching network and the circuit switching network. So, the idea of the circuit switching network was to use specific path for a specific flow. Now, by looking into multiple fields in the packet header, like the MAC source, MAC destination, Ethernet type, IP source, IP destination, TCP source port, TCP destination port, by looking all these individual fields, you can actually uniquely identify a process to process flow, because you are also associating the TCP source port and the TCP destination port. Now, for that particular flow, you can make an action that forward the packet for this particular flow to this switch. So, that means you can make flow specific forwarding or flow specific routing of the data. So, that is a huge power of SDN based network. Then you can do the source routing where if the packet is coming from a specific source and it is destined to a specific destination, then you use a specific part. So, you put the source IP, the destination IP, if the packet is coming from a subnet at 16.2.3.star and if the destination is 202.2.star, the action is forward the packet to Ethernet 2. You can do the VLAN switching, although till now we have not discussed about what is VLAN, virtual LAN. Virtual LAN is basically given a packet, a set of packets. If you want to send a set of packets or a packet to a specific destination, you can forward the packets into multiple ports of the switch, which constructs virtual LAN. So, later on we will look into the virtual LAN in details, but with the help of this open flow rules, you can specify the virtual LAN ID, the corresponding MAC destination, and the action is forwarding the packet to two different ports, ETH2 and ETH3. That means, ETH2 and ETH3 are actually connected to virtual LAN 2. So, the packets will be forwarded to those interface only. Now, these are the examples of some of the open flow rules. You can design your own open flow rules and the corresponding action. The entire innovation is open, so anyone can contribute there. Let us look into the messages which are there in general. Open flow, the messages which are shared between the controller and the corresponding switches. So, this communication, as you are mentioning, they are done via TCP. So, once you have made a TCP connection between the client version of the switch and the controller, the open flow hello messages are exchanged between the controller and the switch. So, they negotiate the open flow version, the higher version is used, and they share certain parameters like what are the different configuration parameters you want to share. Then the controller sends a open flow feature request message. The feature request message to get the data path ID of the switch and determine what features are supported by the switch. Say for example, whether the switch supports QoS based forwarding or not. Now, based on the application program, you can send certain OpenFlow messages for switch configurations to update the flow entries, to modify the flow entries, or to install a new flow entries. There are some other messages like to check the connection aliveness, whether the connection is alive or not. OpenFlow can send echo request and echo reply messages. They can be sent from the controller to switch to check the liveness of the switch, or the switch can send it to the controller to check the liveness of the controller. Now, to group the flow entries, if you want to group multiple flow entries together, these groups are configured by the controller to these group configuration messages that can be stored into group tables inside switch. So, OpenFlow has a power that you can combine multiple rules altogether and create a group of rules. So, the messages are there to support that group creation. To get the statistic details from the switch, you have these OpenFlow messages like flow stats, port stats, queue stats, group stats, table stats, all these things that can be sent from the controller. So, that is another advantage, like from the controller you can get the statistics from the switch and you can look into the individual statistics that for a particular flow how many packets has been transferred, and based on that you can also configure the switch for restricting the bandwidth for a particular flow. So, you have as a network administrator you can get a tremendous power to control your network. Then there are certain asynchronous OpenFlow messages like flow rule removal from a switch, configuration apply fail error from the switch, port up down status from the switch, whether a particular port is up or down, etc. that can be sent from the switch to update the controller. So, if a particular port from a switch is down, the switch can send a message to the controller to let it know that this particular port is now down, so that the controller can design a fail safe mechanism for forwarding the packet. So, this is the entire a brief introduction about OpenFlow. So, now what is happening? The entire power is in the hand of network programmer or the network administrator. The network administrator controls the entire controller, write down his or her own program in the controller, and this OpenFlow helps configuring the switches. Now, whenever you are receiving a packet, the packet has the payload and the header. You look into the header, based on the header field you make a match with the corresponding rule and then send a packet in the based on the action which is there, which is mentioned in the corresponding OpenFlow table. So, the rules in the OpenFlow table inside the switch, they are implemented as a part of the TCAM hardware. So, TCAM is a programmable memory where you can dynamically program that particular hardware to install the rules. So, this is a very brief introduction of OpenFlow. We will go for certain demo of OpenFlow in the next class. Before going to that, so I am just giving you certain pointers that you can explore yourself to look more details of this entire open innovation in the networking community. This is a kind of advanced topic in network and you should learn that because people predict that our future network is going to be SDN controlled. So, there is a link for Open Networking Foundation where you can find out the different standards, different agendas which are there under the Open Networking Foundation. The OpenFlow specification, the current version is stable version is 1.5.1. You can look into the different messages, their messages type, their functionality, all these things. The ONAS is an popular network controller. You can look into the ONAS details. It is an open source thing. Again, you can just install it in a single machine and start using it. There is another SDN controller called RIU. I suggest you to look into the RIU controller as well. So, these are all open source tools. You are free to download them, free to use them. So, explore them. That is all about the course today. Thank you all for attending the course. Happy learning.